Hello everyone, welcome to another lecture of our course Basic to Advanced Level Real Analysis. Today, lecture number 6. In this lecture, we will discuss about subsequences and Limsup and Liminf. The full course divided into 4 parts: Part 1, Part 2, Part 3, Part 4. Part 1 में हम लोग कवर करेंगे सेट थ्योरी, रियल नंबर सिस्टम, सीक्वेंस सीरीज, कॉन्टिन्यूटी एंड डिफरेंशिएबिलिटी। पार्ट 2 पे हम लोग कवर करेंगे रीमान इंटीग्रल, टोपोलॉजी ऑफ रियल नंबर्स। पार्ट 3 में हम लोग कवर करेंगे काउंटेबल सेट, अनकाउंटेबल सेट, एंड पार्ट 4 में कवर करेंगे सीक्वेंस सीरीज ऑफ फंक्शन एंड फंक्शन ऑफ बाउंडेड वेरिएशन। जैसे कि आप लोग देख पा रहे हैं, पार्ट 1 एंड पार्ट 2 इज फॉर जैम एंड नेट, and part 3 and part 4 are for only for net. So अभी हम लोग पार्ट 1 पे है, जहाँ पे हम लोग फंक्शंस, रियल नंबर सिस्टम, सीक्वेंस सीरीज, कॉन्टिन्यूटी और डिफरेंशिएबिलिटी डिस्कस करेंगे। हम लोग ऑलरेडी फंक्शन एंड रियल नंबर सिस्टम कवर कर चुके हैं, अभी हम लोग सीक्वेंस पे है। इन द लास्ट लेक्चर विच वॉज लेक्चर 5, आवर टॉपिक ऑफ डिस्कशन वाज सीक्वेंस इंट्रोडक्शन। वहाँ पे हम लोग देखे थे सीक्वेंस क्या होता है, बाउंडेड सीक्वेंस, अनबाउंडेड सीक्वेंस क्या होता है, उनका एग्जांपल देखा था, थ्योरम देखा था। उसके बाद हम लोग कन्वर्जेंट सीक्वेंस देखे थे, सैंडविच थ्योरम देखे थे। उसके बाद कुछ इंपॉर्टेंट लिमिट फाइंड करे थे, एंड बाय रेशियो टेस्ट हम लोग इस लिमिट को फाइंड किया था, एंड आखिर में देखे थे मोर्टन कन्वर्जेंस थ्योरम। If you want to see it, you can watch our playlist full length real analysis course. Now, today in lecture 6, our topic of discussion is, first हम लोग देखेंगे what is a subsequence and its consequences regarding this. उसके बाद हम लोग subsequence की मदद से इस लिमिट को फाइंड करेंगे। उसके बाद subsequence के जरिए हम लोग देखेंगे limsup एंड liminf क्या होता है, एंड 2 टाइप्स ऑफ सीक्वेंस का कैसे हम लिमसुप एंड लिमिन्फ फाइंड कर सकते हैं, एंड आखिर में देखेंगे कॉची सीक्वेंस क्या होता है एंड इट्स इम्पोर्टेंसी। सो हम लोग जो बुक यहाँ पे रेफर कर रहे हैं वो है रियल एनालिसिस बाय एस्किमापा, मैथमेटिकल एनालिसिस बाय मलिक अरोड़ा, एंड रियल एनालिसिस बाय बार्टले एंड सोबर्ट। यू कैन फॉलो दिस बुक। सो यू कैन डाउनलोड दिस नोट्स व्हाट वी हैव डिस्कस्ड इन दिस लेक्चर from our website www.mathnospedia.in। लिंक डिस्क्रिप्शन में मिल जाएगा आप लोगों को। आप लोग व्हाट्सएप ग्रुप भी ज्वाइन कर सकते हो फॉर रेगुलर नोट्स एंड अपडेट्स, एंड फॉर एनी क्वेरी और डाउट यू कैन मेल मी एट mail@mathnospedia.in। I will try to solve your doubts. So without wasting any time, let's start today's lecture. So first thing is that what is a subsequence? Suppose xn be a sequence and n1, n2, n3 be a subset of n, such that n1 less than n2 less than n3, so that n1, n2, n3 are increasing sequence. Then xnk will be a subsequence of xn. That means if you take natural number set 1, 2, 3, 4, 5 like this, and if you take a subset from this like 2, 4, 5, 6, then the corresponding sequence x2, x4, x6 will be a subsequence of any sequence xn. Okay. Now, an important theorem to remember that if a sequence xn converges to x, then any subsequence of xn always converges to x. And also, if any subsequence converges to x, then the sequence will be also convergent. So, the converse is also true. So, using this, we can say that a sequence does not converge to x if there exists a subsequence of xn such that it does not convergence to x. That means आपको कोई भी एक सीक्वेंस का अगर एक सबसीक्वेंस मिल जाता है जो कि उस x पे कन्वर्जेंट नहीं होता, then you can say that the beginning sequence is not convergent. Okay. Now let us see this example. How can we calculate this limit? Limit n tends to infinity 1 plus 1 by n square to the power n square. What will be the limit? So यहाँ पे suppose xn is equal to n plus 1 by n to the power n. Then if you replace n by n square, then you will get x n square is equal to 1 plus 1 by n square to the power n square. So here note that we have already seen in the last lecture that the limit n tends to infinity x to xn is equal to e. Now, so as the sequence xn converges to e, so any subsequence which is xn square is a subsequence of xn also converges to e. So that's why we can write limit n tends to infinity xn square is equal to e, and hence we can say that limit n tends to infinity 1 plus 1 by n square to the power n square is equal to e. This completes our result that the given limit is also e. Now, what is Bolzano-weir theorem? The Bolzano-weir theorem says that if a sequence xn is bounded, then it has a convergent subsequence. That means every bounded sequence has a convergent subsequence. For example, if you take the sequence minus 1 to the power n, then this sequence is bounded because every element of the sequence are minus 1 and 1. So its lower bound is minus 1 and upper bound is 1. Note that it has two subsequences which are एक है minus 1 1 1 minus 1 minus 1 minus 1 and एक है 1 1 1 1 1. Both converges, but observe that it converges to minus 1 and this converges to 1. So the subsequences converges to different limit. That's why the given sequence cannot converge, because we know that by previous theorem that of a convergent sequence every subsequence must be convergent and converges to the same limit, but here the subsequences have different limit. That's why the original sequence cannot be a convergent sequence. We have already know that the sequence is bounded but not convergent. Remark that a bounded sequence can have infinitely many convergent subsequences. So the Bolzano-weir theorem says that it has at least a subconvergent subsequence. So in general, the bounded sequence can have infinitely many convergent subsequences. Okay. Now, what is Limsup? What is Liminf? Let xn be a bounded sequence, and suppose S be the set of all subsequential limit, then lim sup xn is equal to sup s, and lim inf xn is equal to inf s. What that mean? अगर कोई भी एक बाउंडेड सीक्वेंस का आप लोग सबसीक्वेंशियल लिमिट लेते हो, मतलब suppose xn is a bounded sequence and it has subsequences like this xn1, xn2, xn3, then every subsequence will have some limit. Okay, if it exists. If it does not exist, then we can't say that it has lim sup or lim inf. If the subsequent limit exists, then suppose it converges to L1, xn2 converges to L2, xn3 converges to L3. Then if you take a capital S is equal to L1, L2, L3, that means the set of all subsequent limit, then lim sup क्या होगा? lim sup होगा इस सेट का सुप्रीमम and lim inf होगा इस सेट का infimum. Okay, this is the basic definition of lim sup and lim inf. Note that A bounded sequence is convergent even only if limsup xn is equal to liminf xn. Okay, एक सीक्वेंस तभी कन्वर्जेंट होगा अगर both limsup and liminf exist and they are equal. For example, if you take 1 by n sequence, then its both limsup will be 0, converges to 0, and liminf also will be 0. And as they are equal, the original sequence will also converges to 0. Now let us see an example of type 1. Suppose you have the sequence an is equal to minus 1 to the power n, 1 plus 1 by n. Okay. Now observe that depending on the value of minus 1 to the power n, this sequence will have the number of subsequence. Depending upon the value of n, whether it is odd or even, it will have 1 and minus 1. That's why it will have two sequences. So one for n is equal to 2k, that is for even, and one for n is equal to odd, that is for n is equal to 2k plus 1. So if you take n is equal to 2k, then your sequence will be a 2k is equal to minus 1 to the power 2k into 1 plus 1 by 2k to the power 2k. As minus 1 to the power even is equal to 1, you will have this ultimately. Now if you take limit as k tends to infinity, then you will get L1, the subsequential limit of a to k, will have e, because we already know that limit k tends to infinity 1 plus 1 by k to the power k is equal to e. By similar argument, 1 plus 1 by 2k to the power 2k will also go to e. You can also check the e, यहाँ पे सबसीक्वेंस का डेफिनेशन लगा के भी आप प्रूफ कर सकते हो, जैसे कि हमने ऑलरेडी इन द अबव प्रूफ किया कि लिमिट 1 plus 1 by n to the power n square to the power n square goes to e. By similar method, L1 here is e. Now if you take n is equal to 2k plus 1, then you will get minus 1 to the power 2k plus 1 plus 1 plus 1 by 2k to the power 2k plus 1, which will give you this, because minus 1 to the power odd is minus 1. So if you take limit k tends to infinity, you will get L2 as minus e, like this. Okay, so here you get S is equal to set of all subsequences, so limit is equal to e and minus e. Now e is the supremum of the set and minus e is the infimum of the set S. That's why limsup xn is equal to sup S is equal to e, and liminf xn is equal to inf S is equal to minus e. अब अगर सुप्रीमम और इन्फीमम के बारे में डिटेल्स में जानना चाहते हो तो इस वीडियो को आप देख सकते हो, जो कि यहाँ पे हम लोग डिस्कस किया था LUB और सुप्रीमम के बारे में एंड GLB और इन्फीमम के बारे में. ओके, सो प्लीज वॉच द वीडियो. Next, let us see another example which is of type 2. If you given like sequence n is equal to cos 2n plus 2n pi by 3. So here the subsequences will be depending upon the periodic nature of cos function. This is the way to find trigonometric subsequences. Remember that the periodic of cos is 2k pi. So if you equal 2n pi by 3 is equal to 2k pi, you will get n is equal to 3k. Okay, that is multiple of 3. So if you take like this 1, 2, 3 will be distinct pair of n for which you can find the distinct subsequences. That's why we will take 3 number n is equal to 3k plus 1 another and n is equal to 3k plus 2. So n is equal to 3k plus 1 and 3k plus 2 will constitute all the subsequences, distinct subsequences of the sequence an. So first take an is equal to 3k. Then what will happen? A 3k will give you cos 2k pi, and we know that this value is minus 1 to the power 2k, which is even. That's why this is 1. So the first subsequential limit will be 1. Okay. Next, if you take the sequence for n is equal to 3k plus 1, then you will get a 3k plus 1 is equal to cos 6k pi plus 2 pi by 3, which is nothing but cos 2k pi plus 2 pi by 3 is equal to cos 2 pi by 3, whose values is by trigonometry minus half. So the second limit will be minus half. Similarly, for n is equal to 3k plus 2, you will get a 3k plus 2 is equal to cos 6k pi plus 4 pi by 3 is equal to cos 2k pi plus 4 pi by 3 is equal to cos 4 pi by 3, which is again minus half. So the third subsequential limit is also minus half. So that's why all the subsequential limit of the sequence an will be minus half and 1, and its infimum is minus half and supremum is 1. That's why lim-sup xn is equal to 1 and lim-inf xn is equal to minus half. Okay. Now, what is a Cauchy sequence? Remember that any sequence xn is said to be Cauchy if for every epsilon greater than 0, there exists a natural number n belongs to n such that xn minus xm less than epsilon for all n greater or equal to n. What that mean? That means that for any sequence xn, if the sequence comes closer after a certain stage, that means you are starting the sequence from n1, n2, n3. So after certain stage, you will get a neighborhood where the sequence xn, xm will come closer to each other. Then you can say the sequence xn is Cauchy. Okay. Now the example is the sequence 1 by n is Cauchy. Let us prove this 1 by n is Cauchy. Suppose epsilon greater than 0 be given. Here xn is equal to 1 by n. So if you put m in place of n, you will get xm is equal to 1 by m. Now let us calculate what is xn minus xm. Okay. The xn minus xm is 1 by n minus 1 by m, and this will give you lesser or equal to 1 by n plus 1 by m, because we know that for any real number a minus b lesser or equal to mod a plus mod b, because here is n or m are natural numbers, so mod will not be there. That's why lesser or equal to 1 by m plus 1 by n. Now by Archimedean property, which we have already learnt in this lecture, you can see that if any epsilon greater than 0 a real number, then there exists a natural number n belongs to n, and you can take any other natural number 2 such that n comma epsilon will be greater than that 2. Then if you simplify that, you will get epsilon greater than 2 by n. That means 2 by n less than epsilon, this will imply 1 by n is less than epsilon by 2. Okay. Similarly, we can say that 1 by m is also less than epsilon. So by Archimedean property, we can write this as less than epsilon by 2 plus less than epsilon by 2, which will give you epsilon. And hence, we can say that xn minus xm less than epsilon for any n comma m. Okay, that's why 1 by n is a Cauchy sequence. Okay. Now, important theorem regarding Cauchy sequence is that a real number sequence xn is Cauchy if and only if it is convergent. Very big. Only in case of real number sequence xn will be Cauchy if and only if it is convergent. That means Cauchy होगा तो convergent होगा. Cauchy will imply convergent, and convergent will imply Cauchy. This is very important. Using this result, observe that example. The sequence log n is not Cauchy. Why it is not Cauchy? Because log n goes to infinity as n tends to infinity. That's why log n is an unbounded sequence. This is unbounded. So unbounded means this is not convergent, because we know that every convergent sequence is bounded. So this is not convergent. So as it is not convergent, it is not Cauchy. That's why log n is not a Cauchy. So that's it now for today. Hope you understand. In the next lecture, we will discuss PYQ previous year's question on sequences from JAM and csir-net. Till then, goodbye.